Okay, in this final lecture, we will look at the anchor beam analysis after the hoisting and decking processes, and in the early strength, with the early strength values of concrete. So first, for flexure, we'll follow the same process as the anchor design section under the different loading condition. We're going to have the same assumption that the tension steel yields, taking phi as 0.9, and we'll have to double check that in order to confirm that the tension steel is yielding, and we can use that that phi number. And then for ease of analysis, once again, we'll take the moment about the centroid of the concrete compression block in order to find our section capacity. Once again, I've drawn out, and this is actually incorrect. Remember, we're going to be taking the section that's the smallest. Section that's the smallest rectangle within you get the idea, within the anchor, and we'll use that to find our section and run our analysis. Once again, I've drawn out the stress strain diagrams. We're actually going to ignore that top steel for simplicity, ignore that compression steel, and look at this as a singly reinforced beam. We can ignore this section here, and we can rearrange our MN in order to back calculate the amount of days we need to have sufficient capacity. And as you may remember from the anchor design section, this equation will apply also for we'll call it FST, the tension steel, and epsilon ST for the tension steel, and we want to use that to confirm that our tension steel is yielding, so we can use a phi value of 0.9, and we'll do that by similar triangles. And for the shear condition, we'll follow the same process as the anchor design as well. Under the different loading, we can rearrange, and this is the same process that I've outlined in the anchor design section. We first want to see if we need reinforcement required at all, and if we do, we can add the shear strength of the reinforcement into our equation. So when we're checking our capacity, our Vn is now the shear strength of the concrete plus the shear strength of the reinforcement. And we can rearrange that to find our F prime C required. And then finally, for cable pullout and bearing, we are going to, as you may guess, follow the same process from the anchor design section under the new loading condition, and we just want to make sure that we are checking using the 1.4 dead load combination. We want to checking that our bearing capacity times the load factor is greater than our load experienced. These are the equations, once again, from ACI 318 2011, and I mentioned this in the anchor design section, and I'll mention it again here. We want to make sure for this specific case that we are looking not just at the all of the cable forces, but we want to be looking at a single cable force. We want to be breaking that up, and we can look at what is most conservative, whether that's a handrail cable or walkway. It'll be the handrail, so I have hand mentioned in here, because we're using the handrail cable to do this calculation, because it's going to generate the largest force, and it's going to be, so that'll be the most conservative value to look at. And finally, we can rearrange that F prime C required in order to get the amount of days that we need to wait before we can hoist or we can deck.